Welcome folks, so as promised at the end of the last video, we are going to actually use this rational root theorem slash factor theorem. Now the rational root theorem again is basically the factor theorem, but in a more generalized sense, and a more helpful sense, to actually factor this thing. So I wrote out our steps, and this is what we're going to do. We're going to work through them one at a time. So the first step is figure out all the possible roots slash x-intercepts. So let's kind of just work on the side here. So our steps, step one, find the possible roots or x-intercepts. So again, these are values that when I plug them in, I'll get 0 hopefully. Now again, p of x I know is that, and so all the factors are going to look like this. ax minus b, or all the linear factors anyway, times ax minus b and so on. Well, they're not all going to be the same, but and what I do know is that when I multiply all the ax's together, all the leading coefficients, I need to get to 2x cubed. And so I know that a has to be, all the a's have to be factors, factor of 2. Likewise, when I multiply all the constant terms in all of the factors, those have to be factors of 15, because well, all the constant terms multiplied together will end up with the constant term that we end up with, 15. Okay, so that means then, by the way, that ax minus b equals 0. If that is the case, then that means that the actual x-intercept so is equal to, again, b over a. Now, again, the letters don't actually matter. If you set it as a over b and so on, that doesn't matter. But just remember that you're whatever letters you use here, you evaluate the actual x-intercept correctly. Okay, so all the possible b over a's, well, all the possible b's are, let's see, 15, it could be 1 and 15, and they could be 3 and 5, and I think that's all. 1, 3, 5, and 15. Okay. Here's the weird, unfortunate thing, is that they could also be negative. So, for example, it could be 1 and 15, or it could be negative 1 and negative 15. And we have no idea of actually knowing that at this moment. So actually there's 8 possibilities, not just 4, for our possible b values. For 2, that's not so bad. They're only 1 and 2, but again, we have positive 1, 2, and, or sorry, positive 1, negative 1, and positive 2, negative 2. Okay, so now we have all the possibilities. So really, step 2, well, I haven't even gotten there actually. So all our possible b over a's then are going to equal, let's see, I could do 15 over 2, plus or minus, so 15 over 2, plus or minus 15 over 1, plus or minus 5 over 2, plus or minus 5 over 1, 3 over 2, and 3 over 1, again, plus minus. Let's see, what else? And then 1 over 2, plus or minus 1 over 2, plus or minus 1 over 1. And of course, we could simplify these, so this could be, this is really just plus or minus 15. Sorry, plus or minus 15, plus or minus 5, plus or minus 3, and plus or minus 1. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8 options. Actually 16 options, because times 2. Now you might notice, like, how do I know it's not plus, why is it just still plus or minus when it's positive, negative on top and positive, negative on the bottom? Well, if they're the same, if I do negative 15 over negative 2, that's going to be positive. Or, again, positive 15 over negative 2 would be negative. So again, there's only two options. So there's a lot of possibilities. Now all we have to do is check them. Now, if you're really unlucky, you're going to check like 5 of them before you actually find one. And that's kind of just the way it goes. So let's just check 2, because again, I know what the answer should be. But again, step 2 is to check these roots, these possible roots, remember. Step 2, check them. So let's just try, and we're going to try an integer one to make it nice and easy for us. So we're going to try 3. So I'm going to check does P of 3 equal 0? Actually, that's silly. Why would I do 3? We should choose 1 because it's going to make your life easier. So I'm going to try P of 1. And that hopefully will equal 0. Okay, so let's do this. So let's remind ourselves what our function is. So P of x is equal to 2x cubed minus 5x squared minus 8x plus 15. Okay, so let's actually check this. So P of 1. The nice thing about plugging in 1 is that all the powers of x are just 1, and so you can kind of ignore them. So I'll get really just 2 minus 5 minus 8 plus 15. Let's see, I'm going to get 2 minus 5 minus 8, so that's going to be, sometimes you can already kind of tell, negative 8 negative 11 plus 15, so that's going to be negative 4. So what does this mean? This tells us then, so again, this is not 0, not 0, and therefore x equals 1 is not a root, or an x-intercept, not a root, and therefore x minus 1 is not a factor of P of x. Of P of x. Darn. Okay, well, let's try another one. Okay, how about x equals, well, negative 1. Let's try that. So I would check again, P of negative 1 is equal to, let's see, when it's negative 1, let's see, negative 1 cubed is actually negative, so I have to be aware of that. So I'll be negative 2, but negative 1 squared is just positive 1, so I don't care there. Minus 5 plus 8 plus 15. I think we can already kind of see that this is unfortunately not 0. Not 0. And therefore, again, x equals negative 1 is not a root. Not a root. And also, therefore, x plus 1 is not a factor. Okie dokie. So let's try the next one. I guess let's just try 3. Okay, so I'm going to check x equals 3, question mark. All right. So again, I will check P of 3, which equals, again, now I'm going to have to write this one out. 2 times 3 cubed minus 5 times 3 squared minus 8 times 3 plus 15, sorry. Let me just still check I plugged into my function correctly. Minus 5, minus 8. All right, cool. So once we do this, we'll get, let's see, 2 times 27, so 54, minus, let's see, this is going to be 5 times 9, so 45. 45 minus 24 plus 15. I'm going to be really lazy, and I'm just going to check my calculator here. So I have 54 minus 45 minus 24 plus 15. And hey, unless I put it into my calculator wrong, that actually is 0. Thank goodness. Okay. So as you can see, sometimes it takes a while before you can get there. And is it always obvious as to which one you should start off with? Not really. As far as that, I mean, maybe you might be able to develop a kind of gut feeling for where you should start. But for me, I'd say just start with whatever's going to make your evaluating easier. So start small. Okay. So now we have this. So we have, again, x equals 3. Let's see what this means. Is a root, and therefore x minus 3 is a factor. X minus 3 is a factor. Therefore, we can say that P of x eventually factors into x minus 3 times stuff, something. Now, how do I find this something? That's where step 3 is. Divide by the factor that you found in step 2. You found in step 2. Okay, so we're going to do that. So step 3 now. And you might have also noticed that this takes a lot of room on your paper. I'm writing very big, so it does for sure. Yours will take a little bit. Well, actually, I don't want to get your hopes up. It will take a lot of space. So we have P of x. Remember that. Oh, by the way, to find the other stuff, remember that stuff the other piece is simply p of x divided by x minus 3. So that's why we need to do this. So p of x, I do that. I will use, should I use the boxes or the long division? Oh yeah, well, what the heck, I'll use the boxes. I like using the boxes every so often. X and then negative 3. We're gonna figure out what goes on top here. Like so. And again, we're gonna want to get eventually 2x cubed minus 5x squared minus 8x plus 15. And again, I like to stagger this. Okay, so we need to get the 2x cubed. So I'm going to need to multiply the x by 2x squared to get to here. So that'll be 2x cubed. Follow that through again. So 2x squared times negative 3 will be negative 6x squared. Let's see. I need negative 5x squared, and I already have negative 6. So I need to get rid of one of those negative ones by adding 1. So plus an x squared. How do I get to x squared from x? Well, I multiply by x. Negative 3 times x will get us a negative 3x. I have negative 8x, or sorry, I will have negative 3 and I want to get to negative 8. So I need to take away 5 more. I get to negative 5x by doing x times negative 5, and I will get 3 times, negative 3 times negative 5 will get us to that last 15, which is necessary. By the way, if you do this and you get a, so by the way, with the boxes, when I'm looking for this, I'm looking for this constant term to match, and then that tells me there's no remainder. If you do this division and you get a remainder that's not 0, you messed up somewhere. Because again, if it's a factor, that means there should not be a remainder. And so what we have done is we now know that p of x is equal to x minus 3 times 2x squared plus x minus 5. Last step is we repeat if possible, and if we once we get to a quadratic, well, I guess we're kind of done here, because I said, at least in my steps, repeat until we get to a quadratic. We got to the quadratic already, and the last step is factor it if possible. Step 5, factor 2x squared plus x minus 5. So it might be factorable and it might not be, but let's just double check using our discriminant. So I use our discriminant test or discriminant check. So b squared minus 4ac. And I'll get, let's see, that'll be 1 minus 4 times 2 times negative 5. So be careful here. So let's see, that's going to be, I can't think right now. So this is negative 10 times 4 is 40. So that'll be plus 40 equals 41, and that's not a perfect square. Not a perfect square. And therefore, it is not factorable. Not factorable. We can now conclude that this is the final factored form. It takes a while, it absolutely does, but once you get the hang of it, it's really not too bad. Really, this is really the worst part here, is checking those possible roots, but there's no real way around it. There actually is eventually a faster way, but for now we're just gonna do it this way because that faster way is it's almost like math magic, kind of hand waving. I don't quite like it as much. This is just you gotta get your hands dirty sometimes, and this is an example of one of those times. So thanks for watching. I hope this helps, and I will see you folks in a later video. Thanks for watching.